The new discoveries about 3I Atlas have revealed something that changes everything we thought we knew about how life begins in the universe. Is that poison that 3I Atlas released? Now we see this interstellar visitor is carrying the seeds of life, the molecular building blocks that make biology possible, the chemical precursors that could trigger the emergence of living systems on worlds that are currently barren, but that might not remain barren if these molecules arrive and find conditions favourable for their transformation into something more complex. And this discovery isn't just academic curiosity about what interstellar objects are made of. It's evidence that supports one of the most profound theories in astrobiology, the theory that life doesn't originate independently on every world where it exists, but is instead distributed across the galaxy by objects exactly like 3I Atlas. Objects that carry organic chemistry from stellar system to stellar system, that seed planets with the ingredients needed for biology to emerge, that might be responsible for life on Earth itself. Hit like and subscribe for more sleepy explanation. Recently, an astrophotographer captured images of 3I Atlas from Egypt's Black Desert. In those images, you can see a green object in the Egyptian sky. That's 3I Atlas. Glowing green from emissions we'll discuss later, visible to careful observers in dark locations far from light pollution. But the real story isn't what amateur astronomers are seeing with their cameras. The real story is what one of the world's most powerful radio telescope arrays detected when it turned its attention to this mysterious visitor. What it found when it analysed the chemistry of the gases surrounding the nucleus. What it revealed about the organic molecules that 3I Atlas is carrying through our solar system. Before we dive into the chemistry, before we examine what these molecules mean and why their presence is so significant, and what implications this has for understanding how life spreads through the galaxy, you need to subscribe to this channel right now, because what we're documenting here isn't just interesting astronomical observation about unusual comet. This is potential evidence that panspermia is real. That life's origin on Earth might not be purely terrestrial, that the molecules required for biology arrived from space-aboard objects that we're only now learning to recognize and study. And if you want to follow this investigation as it develops, as new observations reveal more about what 3I Atlas contains, and what that means for our understanding of life in the universe, you need to be here. Hit subscribe, enable notifications, give this video a like because engagement tells the algorithm that people care about these questions. This matters more than you might realize. A few days ago, one of the most powerful instruments for studying molecular chemistry in space turned its attention toward 3I Atlas, the Atacama Large Millimeter Array, ALMA. Located in the Chilean desert at altitude where Earth's atmosphere is thin enough that it doesn't block the wavelengths the telescope needs to observe, ALMA consists of 66 radio dishes working together as a single instrument, combining their signals to achieve resolution and sensitivity that no single telescope could match. And when that combined instrument focused on 3I Atlas, when it performed spectroscopy on the gases the object is emitting, when it analysed the molecular signatures in those emissions, what it found made scientists' hearts race. Spectroscopy is how we determine what things are made of from vast distances. When molecules emit or absorb light, they do so at specific wavelengths determined by their quantum mechanical properties. Each molecule has unique spectral fingerprint. By analysing which wavelengths are present or absent in light coming from astronomical object, we can identify what molecules exist there, even though we can't physically sample them. It's detective work using physics. It's reading chemical composition through light itself. And ALMA is extraordinarily good at this kind of detection, because it operates at wavelengths where many molecules produce their stronger signatures. The spectroscopic analysis of 3I Atlas revealed two particularly significant molecules. First was methanol, CH3OH, simple alcohol. 4 atoms of hydrogen bonded to carbon that's bonded to oxygen, and another hydrogen. Second was hydrogen cyanide, HCN. Even simpler, hydrogen, carbon, nitrogen in linear arrangement. Neither molecule is exotic from chemistry perspective, both are well studied. Both appear in various contexts throughout the universe, but finding them together in 3I Atlas is significant because these two molecules are exactly what you'd expect to find if an object is carrying the precursors to more complex organic chemistry. Now, these molecules typically form in very cold environments, form in interstellar space where temperatures are close to absolute zero, form on surfaces of dust grains that are coated with ices, form through reactions that occur when atoms and simple molecules freeze onto grain surfaces and then interact through processes that don't require liquid phase or high temperatures. They're products of ice phase chemistry. Chemistry that operates in frozen environments through mechanisms that are completely different from the liquid phase chemistry we're familiar with from terrestrial experience. And both molecules are considered to be among the first steps in building the complex organic chemistry that leads eventually to amino acids, to sugars, to nucleotides, to all the molecular machinery that life requires. The ALMA observations weren't single snapshot, weren't just one measurement that might be ambiguous or uncertain. The telescope observed 3I Atlas multiple times as the object approached perihelion. First observation was August 28, 2025, then September 18th, then September 22nd, then October 1st. 4 separate observation epochs spanning more than a month. And across those observations, patterns emerge that tell story about what's happening to 3I Atlas as it gets closer to the Sun and as solar heating increases and as the molecular chemistry responds to changing environmental conditions. Methanol was detected in that first August 28th observation, was present in the gas surrounding the nucleus, was emitting at wavelengths that ALMA could detect clearly. But in each subsequent observation, the methanol signal got stronger, not just slightly stronger, dramatically stronger. The intensity increased with each observation epoch, as if 3I Atlas was waking up as it approached the Sun, as if solar heating was activating processes that had been dormant during the long cold journey through interstellar space, as if the object was revealing its chemical contents progressively as conditions became favourable for volatile materials to sublimate and escape into the surrounding gas. That progression is exactly what you'd expect from comet approaching the Sun. The heating increases, the sublimation rate increases, more gas gets released. The coma, the cloud of gas surrounding the nucleus, grows larger and denser. The chemical signatures become stronger because there's more material producing them, all completely consistent with natural cometary behaviour. But the specific molecules being detected and the ratios between them are what make 3I Atlas unusual, are what suggest this isn't typical comet even though it's showing typical cometary response to solar heating. Then the telescope detected hydrogen cyanide, found it in the same gas cloud where methanol was present, found the characteristic spectral signature that unambiguously identifies HCN. But hydrogen cyanide showed different pattern from methanol. While methanol increased as the object approached the Sun, hydrogen cyanide showed opposite trend. The signal was strongest in sunward direction initially, but then decreased as the object got closer, was present but was behaving differently, was showing distribution that didn't match methanol's pattern, was creating chemical contrast that revealed something about where these molecules originate and how they're being released from the nucleus. And then came the most intriguing detail, the most revealing observation that tells us something fundamental about what's happening in 3I Atlas's coma. Some of the methanol that was detected wasn't being released directly from the nucleus, wasn't sublimating from the solid ices on the surface, was forming in the gas phase itself, was being created through chemical reactions occurring in the coma up to 250 kilometers away from the source. That's enormous distance. That's chemical processing happening in the gas itself, rather than just material being released from solid phase. Meanwhile, hydrogen cyanide showed completely different spatial distribution, was concentrated right at the nucleus, was coming only from the solid ice sublimating from the surface, wasn't showing the extended distribution that methanol displayed, was revealing that it originates from deep within the object's structure, bound tightly, released only when surface material sublimates. Acting like signature molecule that reveals the object's true composition, rather than being produced through secondary gas phase chemistry. That contrast is revealing, tells us that we're not just seeing simple sublimation where whatever's on the surface gets released as gas and disperses. We're seeing active chemistry. We're seeing molecules being created and transformed as they interact in the coma. We're seeing that the molecular inventory we detect doesn't necessarily match what's in the solid nucleus, because gas phase reactions are modifying the chemistry. And that complexity, that evidence of active processing, is exactly what you'd expect if the object contains rich organic chemistry that's capable of producing variety of molecules through multiple pathways as conditions change. From August through October, as the observations accumulated, the methanol intensity increased dramatically, not linearly, not gradually, but in accelerating pattern that suggested the sublimation was ramping up rapidly as solar heating intensified. Like 3I Atlas was turning on its methanol engine at full power. Like the closer it got to the sun, the more aggressively it released this particular molecule. That behavior is unusual. Typical comets show increasing activity as they approach the sun, but not with the dramatic acceleration that methanol displayed. Something about 3I Atlas's compositional structure is causing methanol to be released preferentially and increasingly as solar distance decreases. But the real shock came when scientists calculated the ratio between methanol and hydrogen cyanide. When they compared the relative abundances of these two molecules, when they checked that ratio against the catalogue of every comet that's been studied spectroscopically, because the ratio was unprecedented, was larger than any comet we've observed before, was so extreme that it placed 3I Atlas in category by itself, not just slightly unusual, dramatically different, outside the range of natural variation that we see across all the comets in our sample. This isn't just another interstellar traveller that happens to have interesting chemistry. This is object whose molecular composition doesn't match the pattern established by hundreds of observations of solar system comets, and by the handful of other interstellar visitors we've studied. This is something carrying chemistry that's unique. That reveals formation conditions or evolutionary history that differs from what produces typical comets. That suggests origin in environment where the molecular processing created ratios we don't see in objects formed in our own stellar system. And this carries profound implications. Because if 3I Atlas's chemistry is unique, if the methanol to hydrogen cyanide ratio is outside the range of what we observe elsewhere, then either its formation environment was unusual, or the molecular processing it's undergone during its journey has altered its composition in ways that typical comets don't experience. Either way, we're learning that interstellar objects can carry chemical signatures that reveal their exotic origins. That tell us they come from places where conditions differ from what we experience in our local cosmic neighbourhood. Now, before you comment asking whether aliens sent this object to seed planets with life, whether this is deliberately engineered biological payload rather than natural accumulation of organic molecules, let me give you the scientific framework for understanding how such objects might function in distributing life across the galaxy, even if they're completely natural. Because the theory isn't about intentional seeding by technological civilizations. The theory is about physics and chemistry and statistics operating across billions of years and creating outcomes that look purposeful, even though they emerge from blind processes. The theory is called panspermia, from Greek words meaning seeds everywhere, the idea that life doesn't originate independently on every planet where it exists, but instead gets distributed through space. That the molecular building blocks of biology, or perhaps even microorganisms themselves, can survive interstellar journeys, can travel from stellar system to stellar system aboard comets or asteroids or debris from planetary collisions, can arrive on worlds that are suitable for life and can trigger biological emergence, or can directly colonize if they're already living when they arrive. This isn't fringe speculation, isn't pseudoscience or wishful thinking by people who want to avoid confronting how rare life might be. It's serious hypothesis that's been explored by respected scientists, including Nobel laureates. It's framework that's consistent with everything we know about how organic molecules behave in space, and about how impact events can eject material from planets, and about how long organic molecules can survive in harsh space environment if they're protected by ice or rock. The key insight is that certain organic molecules are remarkably stable, can survive exposure to vacuum and radiation, and extreme cold for millions or billions of years if they're shielded, and objects like comets provide that shielding. The ices protect interior material from radiation, the cold preserves molecular structures that would degrade at higher temperatures, the lack of liquid water prevents hydrolysis and other reactions that would break down complex organics. Frozen Comet travelling through interstellar space is essentially a preservation capsule that maintains molecular integrity across vast distances and vast times. And when such object enters stellar system, when it approaches star and begins experiencing solar heating, the ices sublimate. The protected molecules get released, they disperse into space. Some of that material can impact planets, can deliver organic chemistry to worlds that might have suitable conditions for that chemistry to develop further, can provide the molecular starting points that local chemistry then elaborates into more complex structures, and eventually perhaps into self-replicating systems that we'd recognize as life. We know this is physically possible because we've done the experiments. We've exposed organic molecules to space-like conditions. We've frozen them. We've irradiated them. We've tested how long they survive. And the results show that many biologically relevant molecules can persist for timescales relevant to interstellar travel, can make the journey from one stellar system to another while remaining intact, can arrive still capable of participating in the chemistry that leads toward life. We also know that impact events can eject material from planets at velocities exceeding escape velocity. That rocks from Mars have landed on Earth. That material exchange between planets in same stellar system definitely occurs. And computer simulations show that some fraction of material ejected from planets during major impacts can reach velocities high enough to escape the stellar system entirely, can become interstellar travelers carrying whatever chemistry was present on the planet they came from, can potentially deliver that chemistry to other stellar systems millions of years later. So the physics works, the chemistry works. The statistics suggest that over billions of years and across billions of stellar systems, the exchange of organic material through space might be common rather than rare. Might be continuous background process where molecules capable of leading to life are constantly being redistributed through the galaxy. Where life's emergence on any particular world might be triggered by delivery of molecular precursors from elsewhere, rather than by local chemistry starting from simple starting materials. And finding methanol and hydrogen cyanide in 3I Atlas is consistent with this framework. These molecules are exactly what panspermia theory predicts should be present in objects that serve as interstellar delivery vehicles for organic chemistry. They're the building blocks, the level 1 components that can combine and react to form level 2 components, like amino acids and nucleotide bases, which can then combine to form level 3 components like proteins and nucleic acids, which can then organize into level 4 systems that exhibit metabolism and replication and evolution. The discovery of a protoplanetary disk 10,070 light-years away containing methanol provides crucial context for understanding where 3I Atlas might have formed, and what kind of stellar environment produces objects with its unusual chemistry, because this isn't just abstract connection. This is direct observational link between the molecules we're detecting in 3I Atlas and the environments where planetary systems are being born. This is evidence that methanol isn't rare curiosity that appears only in exotic circumstances, but is instead common component of star formation processes, that it's present in the raw material from which planets form, that any planets emerging from these disks would inherit chemistry that includes methanol and related organic molecules right from the beginning. ALMA telescope was the instrument that made this discovery too, observed the protoplanetary disk surrounding young star in early stages of planetary formation, detected methanol in ring-like patterns distributed through the disk, found that these rings existed at distances ranging from 30 to 100 astronomical units from the central star. That's enormous range. That's region where giant planets would form in system like ours, region where Jupiter and Saturn orbit in our own solar system, and finding methanol there, finding it distributed in organized patterns rather than being randomly scattered, tells us about the chemistry that's happening as planets assemble. The rings themselves are significant, aren't just visual features, are locations where specific physical conditions exist, where temperature and pressure and radiation intensity create environment favorable for certain chemical reactions, where molecules freeze onto dust-grained surfaces and interact through ice phase chemistry, where the products of those reactions accumulate because conditions are right for preservation rather than for destruction. The fact that methanol appears in rings rather than being uniformly distributed tells us that its formation is sensitive to local conditions, that it's being created preferentially where specific temperatures or densities exist, that the chemistry is organized by physics even though no intelligence is directing it. And crucially, the observation showed methanol not just in the ring structures but also near the star. Found emissions from the inner regions where planets are unlikely to form because temperatures are too high and because stellar radiation is too intense. That near-star methanol tells us about transport, about how molecules created in the cold outer disk can be delivered to inner regions, about how the chemistry that occurs in different parts of protoplanetary disk gets mixed and redistributed through dynamical processes that move material inward and outward as the system evolves. This is exactly the kind of system where objects like 3I Atlas would form, in the cold outer regions of protoplanetary disk where methanol and hydrogen cyanide and other organic molecules are being synthesized on grain surfaces, where those molecules get incorporated into larger aggregates as dust grains stick together, where comets and asteroids and planetary building blocks accumulate chemistry that was created through ice phase reactions occurring at temperatures close to absolute zero, where the final composition reflects the chemical inventory that was present in the disk, rather than being created later through processes operating on the finished planet, and then some of those objects get ejected, through gravitational interactions, through close encounters with forming giant planets, through instabilities in the disk that send material on trajectories that exceed escape velocity, through any of the multiple mechanisms that computer simulations show are effective at removing material from forming planetary systems. Some fraction of everything that forms in protoplanetary disk doesn't end up in planets or staying in stable orbits, gets thrown out into interstellar space where it travels for millions or billions of years before potentially encountering another stellar system. That's the origin story that fits 3I Atlas, object that formed in protoplanetary disk around some star that we can't identify. That was in cold region where methanol and hydrogen cyanide were abundant. That incorporated those molecules into its ices as it accreted. That was then ejected through collision, or through gravitational perturbation, or through any process that imparts sufficient velocity for escape. That travelled through interstellar space for unknown time before its trajectory brought it into our solar system. That is now revealing its chemical composition as solar heating causes sublimation and releases the molecules that have been frozen in place since the object formed. This isn't speculation. This is scenario grounded in observations of how protoplanetary disks work, and in computer simulations of planetary formation, and in statistics about how many objects get ejected versus retained. The numbers suggest that every stellar system produces far more small bodies than can be accommodated in stable orbits. That ejection is normal outcome for significant fraction of material. That interstellar space should be populated with objects that formed in planetary systems, but that didn't remain there. Objects exactly like 3I Atlas carrying chemistry that reflects their origin even though they're now wandering between stars. The biological relevance of methanol is what makes this discovery particularly significant for understanding how life might spread, because methanol isn't just inert molecule that happens to be present, isn't just spectroscopic signature that we detect without it meaning anything for biology. Methanol is substrate that some organisms can use directly, can metabolize, can build their biochemistry around. There exist bacteria and yeast that are methylotrophs, that consume methanol as their sole carbon and energy source, that have evolved enzymatic pathways specifically for processing this molecule and extracting useful chemistry from it. These methylotroph organisms possess specialized enzymes. Methanol dehydrogenase is the key one, converts methanol to formaldehyde. That formaldehyde then gets incorporated into cellular metabolism through various pathways, gets converted into biomass, gets used to synthesize amino acids and nucleotides and all the molecular components that cells need. The entire biochemistry of these organisms is adapted to function with methanol as primary input, rather than needing the more complex sugars and organic molecules that most life requires. This demonstrates that life is more flexible than we sometimes assume, that biology can adapt to utilize whatever molecular resources are available, rather than requiring specific compounds. That if methanol arrives on planet along with other organic molecules delivered by objects like 3I Atlas, there's no fundamental barrier preventing organisms from evolving to exploit that resource. That the presence of methanol in interstellar delivery vehicles makes them even more valuable as sources of biologically relevant chemistry, because they're not just providing building blocks, but are providing molecules that could directly support metabolism in organisms adapted to use them. And methanol's role extends beyond just microbial metabolism. Plants use it too. When plants are wounded, when their tissues are damaged by mechanical injury or by pathogens, they release gaseous methanol. That methanol functions as signaling molecule, communicates between different parts of the plant, activates defense responses, triggers immune reactions that help the plant resist infection and heal damage. This is sophisticated biological function. This is methanol being integrated into plant physiology in ways that are essential for survival, rather than being incidental or optional. So methanol bridges from purely chemical domain into biological domain. Is molecule that exists in non-living contexts but that life has learned to exploit. That serves as both metabolic substrate and as signaling compound. That demonstrates the continuum between chemistry and biology rather than sharp boundary. And finding it in 3I Atlas means that object carries not just abstract organic chemistry, but molecules that terrestrial biology actually uses. That could potentially support biological processes if they arrived on suitable planet. That make the panspermia scenario more concrete by showing that interstellar delivery vehicles contain exactly the kinds of molecules that biology requires. Hydrogen cyanide's biological significance is more complex and more subtle. In high concentrations, it's poison, interferes with cellular respiration by blocking enzymes in the electron transport chain, prevents cells from generating ATP efficiently, causes rapid cell death if exposure is sufficient. That's why it's known as toxic compound, why it's used in industrial processes that require strong poisons, why it's associated with danger rather than with life-supporting chemistry. But in low concentrations, hydrogen cyanide is different, becomes signaling molecule rather than toxin, functions in plants and animals and microorganisms as communication chemical, participates in biochemical pathways that regulate cellular processes, acts as modulator rather than as inhibitor. The concentration makes all the difference. At parts per billion, it's signal. At parts per million, it's poison. Biology has learned to work with this molecule at concentrations where it's useful rather than harmful, and hydrogen cyanide is prebiotic molecule, is thought to have played crucial role in origin of life chemistry on early Earth, can participate in reactions that produce amino acids, can form nucleotide bases through series of steps that have been demonstrated in laboratory, can contribute to synthesis of other biologically relevant compounds through pathways that operate under prebiotic conditions without requiring existing life to catalyze them. So while it's toxic at high concentrations, it's also essential for getting from pure chemistry to biochemistry, is one of the molecular bridges that theories of life's origin depend on. Finding it in 3I Atlas alongside methanol creates chemical inventory that's strikingly relevant to biology. These aren't random molecules. These are specifically the molecules that prebiotic chemistry theories predict should be important, that laboratory experiments show can lead to more complex organic synthesis, that biological systems have learned to utilize and regulate and incorporate into their metabolism and signaling. The fact that Interstellar Visitor is carrying exactly this chemistry isn't coincidence, is consequence of the same ice phase reactions that produce these molecules operating everywhere in the galaxy, where cold environments and organic starting materials exist. And there's precedent for finding hydrogen cyanide in solar system locations beyond Earth. The Cassini probe detected it on Titan, Saturn's largest moon, world with thick atmosphere and liquid methane lakes and chemistry that's completely different from anything we have on Earth. Found hydrogen cyanide in Titan's atmosphere, where it participates in complex organic chemistry, driven by solar ultraviolet radiation and by energetic particles from Saturn's magnetosphere. That detection showed that HCN isn't restricted to Earth, isn't special terrestrial molecule, is common product of chemistry operating in diverse environments throughout the solar system and presumably throughout the galaxy. So when we find methanol and hydrogen cyanide together in 3I Atlas, when we measure their ratio and find it's unprecedented compared to solar system comets, we're not just cataloguing chemical composition. We're learning about chemistry that's capable of supporting biological emergence. We're detecting molecules that could serve as starting points for prebiotic synthesis if they arrived on suitable planet. We're documenting that interstellar objects can function as delivery vehicles for exactly the chemistry that theories of life's distribution through the galaxy require. Now here's where the story takes unexpected turn into territory that's less comfortable, where chemistry gives way to physics that's harder to explain through conventional frameworks. Because while ALMA was detecting organic molecules, another space agency on the other side of the world was observing 3I Atlas through a completely different kind of instrument, and was seeing something that nobody expected. Something that raises questions about whether this object is as natural as the chemical composition would suggest, or whether there's additional complexity that we're only beginning to recognize. The Japanese Space Agency turned X-ray telescope toward 3I Atlas, not expecting to find much because X-rays aren't typical emission from comets, are usually weak or absent unless the comet is in very close to the Sun where interaction with solar wind is intense. But when the first X-ray images were processed, they showed something astonishing, a faint glow surrounding 3I Atlas, extended emission that wasn't concentrated at the nucleus, but that spread outward in halo pattern, and when they measured the extent of that X-ray emission, it reached 400,000 kilometers from the nucleus. 400,000 kilometers. Let that number sink in. That's roughly the distance from Earth to Moon. That's enormous scale for X-ray emission from comet. Because normal comets, the solar system comets that we've studied extensively, show X-ray halos that extend 10,000 to 15,000 kilometers at most, occasionally up to 20,000 in very active comets under optimal conditions. But never anything close to 400,000 kilometers, never anything approaching the scale that 3I Atlas is displaying. This is 20 to 40 times larger than any X-ray emission from comet has ever been observed to be. This is completely outside the range of normal cometary behavior. This is an anomaly that demands explanation because it can't be dismissed as measurement error or as marginal detection, where uncertainty might account for apparent size. This is clear, unambiguous observation showing a emission pattern that exceeds everything we've seen before by factors that make it qualitatively different rather than just quantitatively unusual. X-rays from comets aren't mysterious in principle. We understand the mechanism. It's called charge exchange. Happens when solar wind ions encounter neutral gas in the comet's coma. The solar wind is a stream of charged particles, protons, electrons, heavier ions, continuously flowing out from the Sun at speeds of several hundred kilometers per second. When these charged particles, particularly the ions, collide with neutral atoms and molecules in the coma, they can capture electrons from those neutrals. That electron capture process produces excited atomic states, and when those excited states decay back to ground state, they emit X-ray photons. The process is well understood, has been studied in laboratory, has been observed in multiple comets, has been modelled theoretically, and the models match observations well for typical comets in typical conditions. So finding X-rays from 3I Atlas isn't itself surprising. The mechanism should operate regardless of whether the comet is from our solar system or from interstellar space. The solar wind doesn't care about the object's origin, will interact with any neutral gas it encounters regardless of where that gas came from. But the scale is what's anomalous. The 400,000 kilometer extent requires explaining, requires either that the gas density in 3I Atlas's coma is much higher than typical comets at that distance from nucleus, or that the solar wind interaction is somehow enhanced beyond normal levels, or that the charge exchange efficiency is much higher than standard models predict, or that we're seeing multiple mechanisms contributing X-rays rather than just charge exchange alone. Each possibility has problems, each requires invoking conditions or processes that aren't typical of cometary behavior. High gas density at large distances would require enormous outgassing rate, would require that 3I Atlas is releasing material far more vigorously than its size and temperature would suggest. And while the ALMA observations showed that methanol production is high, it's not clear that total gas production is high enough to maintain density sufficient for charge exchange out to 400,000 kilometers. The gas should disperse, should become too diffuse for efficient X-ray production at those distances. Unless something is maintaining the density, unless the gas isn't just dispersing freely, but is being somehow confined or concentrated. Enhanced solar-wind interaction could occur if 3I Atlas has magnetic field, if it's magnetized in ways that typical comets aren't. Magnetic fields can affect how solar wind interacts with cometary coma, can create enhanced coupling between the wind and the neutral gas, can increase the rate of charge exchange reactions by altering the trajectories of charged particles, and by creating regions where interaction is more efficient. But comets aren't normally magnetized, are composed of ice and rock and organic material, none of which should generate significant magnetic fields, unless 3I Atlas's composition is unusual in ways beyond just its organic chemistry. Unless it contains materials or structures that typical comets don't have, that's when the supernova fragment hypothesis enters the discussion. Because supernova explosions create conditions that normal stellar evolution doesn't produce, create exotic materials, create magnetic fields, create fragments that get ejected at enormous velocities, create objects that wouldn't form through normal planetary system processes, and if 3I Atlas is supernova fragment rather than typical comet, that would explain multiple anomalies simultaneously. Supernovae produce neutron-rich material, create elements and isotopes that don't exist in normal stellar abundances, create magnetic fields that persist in the ejected fragments because the material has been processed through extreme conditions, create objects that are partially or fully composed of material that's qualitatively different from anything that forms through normal planetary accretion. And fragments from supernova explosions get launched at velocities of thousands of kilometers per second, are ejected with kinetic energies that dwarf anything that gravitational interactions in planetary systems can produce. Now, the velocity of 3I Atlas doesn't match freshly ejected supernova fragment. Those travel at significant fractions of speed of light initially, are moving at thousands of kilometers per second, while 3I Atlas is moving at dozens of kilometers per second. But supernova fragment that's been traveling through interstellar space for millions or billions of years would have slowed down, would have lost energy through collisions with interstellar gas and dust, would have had its velocity reduced gradually over time until it's moving at speeds comparable to typical interstellar objects. And if the fragment encountered dense molecular clouds during its journey, if it passed through regions where interstellar gas density is high enough that drag becomes significant, if it experienced collisions with other objects or gravitational interactions with stellar systems it passed near, all of these processes would contribute to velocity reduction, would bring the fragment down from the thousands of kilometers per second speeds of initial ejection to the more modest velocities we observe in 3I Atlas, would create trajectory that looks like typical interstellar visitor even though the origin was catastrophic stellar explosion rather than planetary system formation. The magnetic properties would persist though, would remain embedded in the material regardless of how much the velocity decreased, because magnetic fields in supernova ejecta are generated by the extreme conditions during the explosion and by the rapid rotation and by the intense currents flowing through plasma. Those fields get frozen into the material as it cools and solidifies, become permanent features of the fragment structure, and if 3I Atlas contains material with these frozen-in magnetic fields that would affect how it interacts with solar wind in ways that pure ice and rock wouldn't, the durability question is significant. If 3I Atlas was just ice, if it was ordinary cometary material like we see in solar system comets, it shouldn't survive billions of years of interstellar travel, shouldn't remain intact through multiple passages near stars where solar heating would sublimate the ice, shouldn't withstand collisions with other interstellar objects that would fragment fragile ice structure, shouldn't maintain coherence through all the processes that should erode or destroy it over cosmic timescales. But if it's supernova fragment, if it contains denser material or exotic phases of matter created under extreme conditions, durability becomes less problematic. Materials processed through supernova explosions can be incredibly robust, can withstand conditions that would destroy normal cometary ice, can persist for billions of years in interstellar environment because they're already survived the most extreme event that matter can experience short of falling into black hole. The fact that 3I Atlas has remained intact despite presumably travelling for immense time supports the hypothesis that it's more than just frozen volatiles. The organic chemistry isn't incompatible with supernova origin. Supernovae produce organic molecules. The ejecta contains carbon and nitrogen and oxygen and hydrogen, contains all the elements needed for organic synthesis, and as the material expands and cools, as it forms dust grains and icy mantles, the same ice phase chemistry that operates in protoplanetary disks can operate in supernova remnants, can produce methanol and hydrogen cyanide and other complex organics through exactly the same mechanisms. So detecting these molecules doesn't rule out supernova origin, just means that the fragment accumulated icy coating during its journey through interstellar space that contained regions where organic synthesis occurred. But this is speculative, is one possible explanation among several for why 3I Atlas shows X-ray emission that's so anomalous. Other explanations exist that don't require invoking supernova origin, unusual composition, unexpected interaction between the methanol-rich coma and solar wind, some aspect of charge exchange physics that we don't fully understand, and that operates differently for interstellar objects than for solar system comets. All possible, all require more data to evaluate properly. All remain viable hypotheses until observations eliminate them. What's clear is that the X-ray emission is real, is measured, is documented, is something that needs explaining regardless of what framework we ultimately decide fits the observations best. And the fact that it's so extreme, so far outside the range of normal cometary behaviour, means we can't just assume that 3I Atlas is ordinary comet with slightly unusual composition, means we need to seriously consider that something fundamental about this object differs from what we're accustomed to studying. Now the story takes another dark turn, takes us into territory where the anomalies stop being just interesting scientific puzzles and start feeling more ominous. Because while astronomers were analysing spectroscopy and measuring X-rays, while the scientific community was debating what these observations mean, something happened that nobody anticipated. Something that created immediate concern and that remains unexplained despite investigation. NASA's MAVEN orbiter around Mars suddenly went silent. December 6, 2025. MAVEN was operating normally, was executing its mission to study Mars's upper atmosphere and how it interacts with solar wind, was sending data back to Earth regularly through Deep Space Network, was in elliptical orbit that takes it from 150 kilometers above Martian surface at closest approach to 4,500 kilometers at farthest point. Standard operations, everything nominal, nothing indicating any problems or anomalies developing. Then MAVEN went behind Mars from Earth's perspective, normal event that happens every orbit. During this occultation period, communication is temporarily lost because Mars blocks the line of sight between the spacecraft and Earth. The radio signals can't propagate through the planet, so there's expected communications blackout lasting however long it takes for the spacecraft to emerge from behind Mars and re-establish line of sight. This happens regularly, is completely routine. Mission Control expects it, plans for it, knows exactly when communication will be lost and when it should resume. But when MAVEN should have emerged from behind Mars, when it should have come back into view and should have re-established contact, nothing happened. Deep Space Network detected no signal. The spacecraft that should have been transmitting telemetry, should have been sending data about its status and about the measurements it was making, was completely silent. No carrier signal, no data, no indication whatsoever that the spacecraft was there and was attempting to communicate. This wasn't normal communications blackout, wasn't just technical glitch where signal is weak or corrupted, but where you can detect that something is trying to transmit. This was complete absence of any detectable emission from the spacecraft, as if MAVEN had simply ceased to exist, as if it never emerged from behind Mars at all, as if something happened during the occultation period that prevented it from resuming normal operations when it should have. NASA's immediate response was to attempt to re-establish contact. Standard procedure when spacecraft doesn't check in as expected. Try multiple times, use different ground stations, command the spacecraft to switch to backup systems. Attempt various recovery procedures that might restore communication if the spacecraft is still functional but is experiencing problems with its primary systems. All the protocols that have been developed over decades of operating spacecraft in deep space. But none of it worked. Days passed. No signal. No response to commands. No indication that MAVEN was receiving Earth's transmissions or was able to respond even if it wanted to. The spacecraft that had been operating perfectly just hours earlier appeared to be completely dead. And that's not how spacecraft failures normally occur. Normally you get warning signs. Telemetry shows degradation. Power systems show declining output. Thermal conditions show anomalies. Something indicates that problems are developing before complete failure occurs. With MAVEN there was nothing. All telemetry was normal right up until the moment it went behind Mars, and then after emerging, or after it should have emerged, there was nothing. Complete silence. No degradation, no gradual decline. No intermediate state where partial functionality remains. Just normal operation followed by complete absence. That's not how hardware fails. That's not what aging components or random malfunctions produce. That's what happens when something catastrophic and sudden occurs that takes the entire spacecraft offline simultaneously. The conspiracy theories started immediately, because MAVEN had photographed 3I Atlas, had used its instruments to observe the interstellar visitor when 3I Atlas passed relatively close to Mars during its trajectory through the inner solar system, had captured images and data that hadn't been publicly released. And now, MAVEN was silent. The timing seemed suspicious. The correlation seemed too convenient. People started suggesting that MAVEN's observations of 3I Atlas had triggered the failure, that somehow the act of observing or photographing the object had caused something to happen to the spacecraft. The theories ranged from reasonable to absurd. Some suggested that 3I Atlas emitted some kind of radiation or field that damaged spacecraft that got too close, or that observed it too carefully. That MAVEN's instruments had detected something they weren't designed to handle, and that exposure had fried sensitive electronics, that there's defensive mechanism built into 3I Atlas that responds to being examined too closely. All speculative, all lacking evidence. But all attempts to make sense of correlation that seemed too precise to be coincidence. Others suggested more exotic possibilities, that 3I Atlas is aware, is intelligent, is artificial object that knows when it's being observed and that takes action against observers, that Maven's failure wasn't accident or natural phenomenon, but was deliberate response by the object being studied. This ventures into territory that science fiction explores, but that serious science hesitates to consider without extraordinary evidence. But the temporal correlation between Maven observing 3I Atlas and Maven failing shortly afterward created environment where such speculation flourished. NASA's official statements were carefully neutral. Described the situation as anomaly under investigation, stated that contact with Maven had been lost and that efforts to re-establish communication were ongoing, acknowledged that the cause was unknown and that multiple possibilities were being evaluated, didn't confirm or deny any specific theories, didn't release the images or data that Maven had collected of 3I Atlas, didn't provide the level of transparency that would have addressed the speculation effectively. And that lack of transparency, that careful neutrality that avoids committing to any explanation, is exactly what fuels conspiracy theories. When official sources won't provide clear information, when they maintain ambiguity despite public interest in understanding what happened, people fill the vacuum with their own explanations, some reasonable, some less so. But all attempts to make sense of a situation where the official narrative is insufficient to explain the observations and the timing. The technical analysis of why Maven might have been particularly vulnerable to whatever happened focuses on its orbit and its mission. Unlike other Mars orbiters that stay in relatively low stable orbits, Maven's elliptical trajectory takes it through the upper atmosphere and out into regions where solar-wind interaction is strong. Its entire purpose is to study how solar wind strips atmosphere from Mars, how charged particles interact with the tenuous upper atmospheric gases, how electromagnetic processes operate in transitional region between planet and space. That mission profile means Maven is exposed to space environment effects that other orbiters largely avoid. Is designed to operate in conditions where radiation levels are higher and where interaction with solar wind is direct, rather than being shielded by atmosphere or magnetosphere. Is specifically positioned to measure processes that could potentially affect spacecraft systems if conditions become extreme. So if something unusual happened in Mars's space environment around December 6th, if there was enhancement of radiation or particle flux or electromagnetic disturbance, Maven would have been the spacecraft most likely to experience effects. And the timing raises uncomfortable question. Because 3I Atlas was passing through the inner solar system during this period, was relatively close to Mars, was emitting its 400,000 kilometre X-ray halo, and its unusual chemistry and whatever other effects we haven't detected yet. If that object creates disturbances in local space environment, if it affects solar wind or electromagnetic conditions in its vicinity, if it's source of some emission or field that we don't have instruments optimized to detect, then spacecraft operating in vulnerable locations might experience effects that spacecraft in more protected orbits wouldn't notice. That's not claiming that 3I Atlas deliberately targeted Maven, isn't invoking intelligence or intent, is just recognizing that if the object has unusual physical properties, if its source of emissions or fields beyond what typical comets produce, then spacecraft that happen to be in positions where they're exposed to those effects might experience consequences, might have systems disrupted, might lose communication, might fail in ways that seem sudden and inexplicable, because we weren't expecting those particular effects and didn't design shielding or redundancy to protect against them. The planetary defense activation adds another layer to the concern, because while Maven was going silent and while scientists were analysing the chemistry in the X-rays, NASA and the European Space Agency and space agencies from multiple countries quietly activated their planetary defense coordination systems, the infrastructure that's supposed to respond to threats from asteroids or comets that might impact Earth, the systems that track potentially hazardous objects and that coordinate international response if intervention becomes necessary. This wasn't announced publicly with press conferences and dramatic statements, was done quietly, through channels that people monitoring space agency activities noticed but that general public largely missed. The coordination systems went from monitoring status to active status. The tracking became more intensive. The modelling became more focused. The communication between agencies increased, all signs that something was being taken seriously, that some threat or concern was significant enough to justify activating systems that normally remain dormant except during exercises and tests. The official explanation, when one was provided at all, was that this was precautionary measure, that 3I Atlas's trajectory needed careful monitoring to ensure it didn't pose any collision risk, that its unusual properties warranted additional attention, that activating planetary defense coordination was appropriate response to uncertainty about the object's behavior, all reasonable, all consistent with proper risk management, but also all vague enough that it doesn't fully explain why activation occurred when trajectory calculations clearly showed that 3I Atlas posed no collision threat to Earth. The object's trajectory has been well established, has been tracked by multiple observatories using multiple techniques. The orbital elements are known precisely, the future path is predictable, and that path doesn't bring 3I Atlas anywhere near Earth, passes well outside our orbit, creates no collision risk. So activating planetary defense systems ostensibly to address collision threat doesn't make sense unless there's concern about something beyond just the trajectory. Unless there's worry that the object might do something unpredictable, unless the defense isn't against physical impact but against something else that planetary defense infrastructure might help coordinate response to. What that something else might be remains unspecified, remains classified or uncertain or deliberately ambiguous. The activation happened, the coordination increased, the monitoring intensified, but the reason beyond the vague official statements hasn't been clearly communicated, and that gap between the response and the explanation creates an environment where speculation flourishes because people recognize that action is being taken but don't understand why, recognize that authorities are concerned but aren't being told what the concern actually is. The anti-tail persistence across multiple observation dates provides another piece of the puzzle that deepens the mystery rather than resolving it. Because 3I Atlas's anti-tail, the structure pointing toward the sun rather than away from it, isn't transient feature that appeared briefly and then disappeared, has been observed continuously from July 23rd, 2025, when the object was 3 astronomical units from Earth, through November 30th, 2025, when it was 2 astronomical units away, has remained visible across that entire period despite changing viewing geometry, and despite the object moving relative to both Earth and Sun. That persistence rules out certain explanations that might account for anti-tail as optical artifact, because artifacts depend on viewing geometry, change when angles change, disappear when you observe from different perspectives, but 3I Atlas's anti-tail remains visible regardless of how Earth's position changes relative to the object, remains present whether we're looking at it from one side or the other, remains structured the same way across different observation campaigns. That's not how optical illusions behave. That's how physical structures behave when they're actually present rather than being tricks of light. Scientists have proposed 2 main explanations for why the anti-tail exists and why it persists. First possibility is small ice particles being ejected from the sunward-facing surface, material that's being sublimated or ejected from the side of the nucleus that faces the sun. These particles would initially move sunward because they are ejected with velocity component toward the sun, would scatter sunlight effectively because they're small and reflective, would create visible trail that points in direction of the sun rather than away from it, and if sublimation is continuous, if the process operates steadily rather than intermittently, the anti-tail would remain visible across extended observation periods. But there's a problem with this explanation. Small ice particles ejected at thermal velocities shouldn't travel far before solar radiation pressure overcomes their momentum and pushes them back, shouldn't maintain coherent trail extending thousands or tens of thousands of kilometers toward the sun, should disperse, should be blown back by radiation pressure within short distance from the nucleus, should create diffuse cloud rather than collimated tail unless something is maintaining their directionality. Unless velocities are higher than thermal sublimation produces, unless some mechanism is accelerating particles to speeds that let them penetrate further sunward before radiation pressure stops them. Second possibility is that anti-tail consists of objects or particles that were left behind, that were shed from 3I Atlas earlier in its trajectory and that are now trailing along the same orbital path but at slightly different velocities. When 3I Atlas experienced its anomalous acceleration, when it gained velocity through mechanism we've discussed in previous analyses, it would have left behind any material that wasn't gravitationally bound, fragments that had separated, particles that had been ejected. Anything that was travelling with the object but that wasn't part of the main nucleus would have maintained the pre-acceleration trajectory while the nucleus moved ahead on the new accelerated path. From our perspective observing this, we'd see a trail of material stretching back along the object's trajectory, a string of particles or fragments marking where 3I Atlas was before it accelerated. And because the acceleration was sunward, because the anomalous velocity gain was in direction toward the sun, this trail of left-behind material would appear as structure pointing toward the sun. Would look like anti-tail, not because particles are moving sunward, but because they're marking the path the object travelled before acceleration changed its trajectory. This explanation fits some observations better than the ejected particle scenario. Explains why anti-tail is stable, rather than varying with rotation or solar distance. Explains why it extends so far because distance isn't limited by radiation pressure, but by how much acceleration occurred and how long ago. Explains why structure persists across months of observation, because the left-behind material isn't being continuously replenished or dispersed, but is just following its ballistic trajectory that was established when it separated from the nucleus. But it also creates questions, because if anti-tail consists of fragments that were shed, what caused them to separate? Normal sublimation doesn't shed large enough fragments to remain visible across millions of kilometers, doesn't create debris trails that persist for months. Comets do shed material, but it's typically dust and gas that disperses rapidly, rather than forming coherent structures. Getting trail of visible fragments requires either that the object fragmented in some way, which we haven't observed directly, or that it's shedding components through mechanism beyond normal sublimation. The green glow that's become increasingly prominent as 3I Atlas approaches closer to Earth adds another layer to the visual characteristics that require explanation. Because the object has transitioned from appearing white or slightly red in early observations to displaying pronounced green colour in recent images. And that colour change isn't arbitrary, isn't just aesthetic feature without physical meaning. It's direct evidence of chemical processes occurring in the coma as solar heating activates emissions from specific molecules. The green colour comes from diatomic carbon. C2. Two carbon atoms bonded together. This molecule is common in cometary comas, is produced when more complex organic molecules are broken down by solar ultraviolet radiation. When methanol and other carbon-containing molecules get photodissociated, when the UV photons have enough energy to break chemical bonds, one of the products is C2 in excited electronic states. And when those excited states decay, when the electrons return to ground state, they emit photons at wavelengths that appear green to human vision. The fact that C2 emission has become stronger means that the photodissociation processes are intensifying, that more organic molecules are being broken down, that solar UV flux is increasing as distance decreases, that the coma is becoming more active and more chemically complex as sublimation rate increases and as more material gets released into space, where it can be processed by solar radiation. All completely consistent with normal cometary behaviour as object approaches perihelion. But the intensity is notable. The brightness of the green emission is stronger than typical for comets at this solar distance. Suggest either that C2 production is particularly efficient, which could indicate unusual abundance of carbon-rich precursors in the ice, or that the coma density is higher than typical, which would provide more material for photodissociation. Either way, it's telling us something about 3I Atlas's composition or activity level that distinguishes it from average comet behaviour. And the transition from white-red to green tracks with the spectroscopic detections. The methanol that ALMA observed increasing across August through October is carbon-containing molecule that would produce C2 when photodissociated. The strengthening green emission correlates with the methanol increase, confirms that what we're seeing visually is consistent with what spectroscopy reveals about the chemistry, creates coherent picture where visual appearance and spectroscopic composition and temporal evolution all fit together into understanding of object that's rich in organic molecules, and that's becoming more active as solar heating increases. But observers who photographed 3I Atlas are also reporting that it's getting brighter overall, not just changing colour but increasing in total luminosity, becoming easier to see. More prominent in images, approaching naked eye visibility for observers in dark locations. And while some of this is geometric, The object is getting closer to Earth, so angular size and apparent brightness both increase. The intrinsic brightness is also increasing because activity is ramping up. Because sublimation is accelerating. Because the coma is growing and becoming more reflective as more gas and dust are released. That brightening creates opportunity for additional observations, for more detailed spectroscopy, for imaging that can resolve structure at higher resolution, for measurements that can characterize properties that were uncertain or ambiguous when the object was fainter and further away. The coming weeks, as 3i Atlas makes its closest approach to Earth, represent optimal observation window. The time when we can collect the highest quality data, the period when answering the questions that have accumulated becomes most feasible, and the astronomical community is mobilizing to take advantage of this window. Major telescopes are scheduling observations, space-based instruments are being directed toward the object. Coordination is happening across facilities and across wavelengths to build comprehensive dataset that captures as many aspects of 3i Atlas as possible while it's optimally positioned. This is once-in-a-lifetime opportunity. This object won't return, won't pass through inner solar system again. Whatever we learn now during this single passage, or we don't learn it at all. The Black Desert observations from Egypt demonstrate that 3i Atlas has reached brightness, where careful amateur astronomers can contribute meaningful observations, where distributed network of observers can provide temporal coverage that no single professional facility can match, where images and measurements from multiple independent sources create redundancy that ensures important features won't be missed, because one observatory happened to have clouds or technical problems at critical moment. That democratization of observation is valuable scientifically and sociologically, creates a situation where evidence is being gathered by community rather than just by authorities, where findings can be verified independently, where the investigation proceeds transparently because data is being collected by people who aren't constrained by institutional policies about what to release publicly, where if something significant is detected, word spreads rapidly through networks that don't depend on official announcements, and that's exactly what's happening. Amateur observers are sharing images, are comparing notes about what they're seeing, are discussing features and changes that they notice across observation sessions, are building understanding collectively that complements, rather than duplicates, the professional analysis, are ensuring that the story of 3i Atlas doesn't remain hidden behind classified observations or delayed publications, but becomes public knowledge as it develops. The correlation between all these elements, the organic chemistry, the X-ray anomaly, the MAVEN failure, the planetary defense activation, the persistent anti-tail, the brightening green glow, creates pattern that's difficult to explain through single framework. Each observation individually might have straightforward natural explanation, but collectively they create picture of object that's simultaneously behaving like comet in some ways, while showing characteristics in other ways that no comet has displayed before. And that mixture of familiar and anomalous is exactly what makes 3i Atlas so compelling and so frustrating to study. If it were completely normal, completely explained by conventional cometary physics, there would be no mystery, no questions beyond the routine characterization that we perform on any new object, no reason for unusual level of attention and concern. But it's not completely normal, shows features that challenge explanations, shows timing that seems suspicious, shows correlation between observations and events that might be coincidence, but that might be indicating something more complex. If it were completely anomalous, completely inexplicable through natural processes, the conclusion that it's artificial would be inescapable. The investigation would shift from characterization to communication attempts, from studying to attempting contact. But it's not completely anomalous either, shows many features that are perfectly consistent with natural processes, shows chemistry that emerges naturally in cold space environments, shows responses to solar heating that match expectations for icy body being warmed. So we're left in uncomfortable middle ground, where natural explanation requires stacking multiple unusual circumstances to account for all observations, where artificial explanation seems premature given that most features are explicable naturally, where the evidence points in both directions depending on which observations you prioritize and which framework you apply, where honest scientific assessment has to acknowledge uncertainty rather than claiming confidence in conclusions that the data doesn't fully support yet. The panspermia implications remain profound regardless of whether 3i Atlas is natural comet or something more exotic. Because even if it's just unusual comet formed in an environment that produced atypical chemistry, it's still demonstrating that interstellar objects carry organic molecules. Still showing that methanol and hydrogen cyanide and presumably many other biologically relevant compounds are being transported between stellar systems. Still proving that the molecular building blocks of life can survive interstellar journey and can arrive in other solar systems where they might seed biological emergence. If objects like 3I Atlas regularly pass through stellar systems, if this visitor is representative of larger population of interstellar wanderers carrying organic chemistry, then panspermia stops being speculative theory and becomes observable process, becomes mechanism we can study, becomes explanation for how life might spread through galaxy that's grounded in direct observation rather than just in theoretical possibility. And that's significant regardless of whether any particular object is natural or artificial. Because the process works either way. Natural objects carrying organic chemistry can seed planets with molecules that lead to life. Artificial objects deliberately designed to carry biological payloads could achieve same outcome more efficiently, but aren't necessary for process to operate. Nature might be doing it spontaneously through normal dynamical processes that redistribute material between stellar systems, through collisions that eject fragments, through gravitational interactions that send comets on escape trajectories, through all the mechanisms that computer simulations show are effective at creating interstellar travelers. And if that's happening, if organic chemistry is being constantly redistributed through the galaxy, then life's emergence on Earth might not have been purely terrestrial, might have been influenced or triggered by delivery of molecules from elsewhere, might represent one instance of process that operates throughout the galaxy wherever conditions are suitable. That's paradigm shift. That's change in how we think about life's origin that has implications for how we search for life elsewhere and how we estimate probability of finding it. Because if life requires only suitable planet plus delivery of organic precursors, rather than requiring suitable planet plus independent origin of those precursors through local chemistry, then the probability of life emerging increases dramatically. The constraint isn't whether planet can produce the required molecules from simple starting materials, which is difficult and might be rare. The constraint is only whether planet is suitable for life and whether it happens to receive delivery of molecules from interstellar sources, which is easier and might be common. That makes universe potentially much more hospitable to life than we've assumed, makes the emergence of biology more probable, makes the search for life more optimistic because we're not requiring each planet to solve the origin problem independently, but are allowing for help from cosmic distribution system that operates continuously. And finding that 3I Atlas carries exactly the chemistry that this system would need to distribute is evidence that the system is real, that it's operating, that we're observing it in action rather than just speculating about whether it might work. The coming days as 3I Atlas makes closest approach represent critical period for answering the questions that have accumulated, for determining whether the anomalies are artifacts of incomplete data that will resolve when better observations become available, or whether they're genuine features that require explanations beyond conventional framework, for testing whether the Maven failure was coincidental, or whether it's actually connected to the object in ways that implications were uncomfortable confronting, for gathering evidence that might shift the natural versus artificial debate toward resolution, rather than leaving it ambiguous. Every major telescope that can observe 3I Atlas is being scheduled. Every wavelength from radio through visible to X-ray is being covered. Every spectroscopic technique that can reveal molecular composition or physical state is being applied. This is comprehensive observation campaign. This is coordinated international effort to characterize the object as completely as possible during the brief window when it's close enough and bright enough for detailed study. This is recognition that we might not get another opportunity to examine interstellar visitor this carefully, and that we need to maximize the scientific return while the chance exists. The optical observations are tracking the brightening and the color changes, are documenting how the green emission strengthens, are measuring the coma's size and structure, are looking for variations that might indicate rotation or outbursts, or other time-dependent phenomena, are building light curves that reveal how brightness changes with time and with solar distance, are creating maps showing how different regions of the coma emit at different intensities, are characterizing the antitail's evolution and whether it maintains constant appearance, or shows changes as the object's trajectory and viewing geometry shift. The spectroscopic observations are focusing on the molecular inventory, are searching for molecules beyond methanol and hydrogen cyanide, are looking for water, for carbon monoxide, for ammonia, for all the volatile species that comets typically contain, are measuring isotopic ratios that can reveal formation conditions and evolutionary history, are tracking how molecular abundances change as solar heating varies, are testing whether the unprecedented methanol to HCN ratio persists or whether it was a transient feature that only appeared under specific conditions. The X-ray observations are attempting to understand the 400,000 kilometre halo, are measuring its spectrum to determine what processes are producing the emission, are tracking whether the size remains constant or whether it varies with solar distance and activity level, are looking for structure within the halo that might indicate how charge exchange is being distributed, are testing whether the emission is symmetric or whether it shows asymmetries that might reveal something about magnetic fields or about inhomogeneities in the coma. The radio observations are searching for emissions that might indicate electrical activity or magnetic fields, are looking for polarization that would reveal magnetic structure, are monitoring for any transient signals that might indicate active processes beyond simple sublimation, are testing whether 3I Atlas emits at frequencies that would be unusual for natural comet, are essentially performing CT-style searches while maintaining scientific framework that doesn't presume artificial origin, but that would detect artificial signals if they exist. The infrared observations are measuring thermal emission, are determining temperature distribution across the nucleus and coma, are tracking how thermal properties change with solar distance, are looking for hotspots that might indicate preferential sublimation from specific regions, are characterizing the dust properties through thermal signatures, are building models of how energy from solar radiation is absorbed and re-radiated, and how that energy balance determines activity levels. All of this data will be combined, will be integrated into a comprehensive picture of what 3I Atlas is and how it behaves, will be analysed collectively rather than each wavelength and each observation being interpreted in isolation, will build understanding that emerges from synthesis rather than from individual measurements. And that synthesis is where the answers to the questions about natural versus artificial origin, about supernova fragment versus cometary ice, about coincidence versus causation in the timing correlations will hopefully emerge. But even with comprehensive data, even with observations across all wavelengths and with measurements of unprecedented precision, some questions might remain unanswered, because the object will pass, will recede beyond the point where detailed study is possible, will fade as distance increases and as solar heating decreases and as activity drops, will eventually become too faint for even the largest telescopes to track effectively, and then it will be gone. Will return to interstellar space where it might travel for millions or billions of years before encountering another stellar system, or before its trajectory brings it close enough to another star that anyone there might observe it, as we're observing it now. That transience is what makes this moment precious. What creates urgency to observe and analyse and understand while the opportunity exists, because we don't get second chances with interstellar visitors. Don't get to schedule follow-up observations years later when we've developed better instruments or when we've thought of better questions to ask. This passage through our solar system is a unique event. This is when we learn what we learn or we miss the opportunity entirely. And the scientific community understands this. Understands that 3I Atlas represents chance to study interstellar object in detail that wasn't possible with Oumuamua because that object was discovered too late and was already receding when we realized what it was. Wasn't possible with 2I Borisov because while we discovered it earlier, we didn't have same diversity of anomalies to investigate. 3I Atlas is giving us longer observation window and more puzzling features and more comprehensive data set than any previous interstellar visitor has provided. This is optimal case for learning what interstellar objects actually are and how they differ from solar system bodies. The implications for planetary defense, for understanding what threats might arrive from interstellar space, are part of why the coordination has been activated and why space agencies are taking the object seriously beyond just scientific curiosity. Because if interstellar visitors can have properties that affect spacecraft, if they can carry risks beyond just impact hazard, if they can create disturbances in space environment that we haven't anticipated, then our planetary defense frameworks need to account for those possibilities, need to prepare for scenarios beyond just tracking trajectories and calculating collision probabilities, the MAVEN failure might be teaching us that. Might be demonstration that objects can affect systems in ways that aren't just kinetic, that electromagnetic effects or radiation or fields or whatever cause the communications loss represent threats that we need to understand and defend against. That planetary defense isn't only about preventing rocks from hitting planets, but is about understanding full range of risks that space environment can present, and about developing capabilities to detect and respond to those risks before they cause damage. If that's the lesson, if MAVEN's loss serves as warning that makes us better prepared for future encounters with unusual objects, then the failure serves purpose even though its tragic loss of valuable spacecraft and of scientific capabilities that were unique. Sometimes we learn through loss. Sometimes the education comes through experiencing consequences that we didn't anticipate, rather than through theoretical analysis that predicts possibilities before they occur. That's not how we'd prefer to learn, but it's often how the universe teaches us that our models are incomplete. The public response to 3I Atlas has been a mixture of fascination and concern. The organic chemistry discoveries have captured attention of those interested in astrobiology and origin of life questions. The green glow and the visual appearance have engaged amateur astronomers and astrophotographers who are documenting the object and sharing images that bring the science to broader audience. The anomalies and the mysteries have attracted those who are interested in unexplained phenomena and who wonder whether we're observing something beyond natural processes. And the concerns about MAVEN, about planetary defense activation, about whether space agencies are being fully transparent about what they know and what they're worried about, have created parallel narrative where some people suspect that official story is incomplete, where they believe that evidence exists suggesting 3I Atlas is more than just unusual comet, but where that evidence is being withheld or downplayed because authorities don't want to cause panic, or because they don't want to admit uncertainty about how to respond to a situation they don't fully understand. That suspicion isn't entirely unjustified. History shows that space agencies and governments do sometimes withhold information, do sometimes maintain classification or secrecy around discoveries or events that have security implications or that might cause public alarm, do sometimes communicate ambiguously rather than transparently when full disclosure would create complications. So when official statements are vague, when coordination happens quietly, when the level of activity doesn't match the level of public communication, people reasonably wonder what's being held back and why. But suspicion can also become disconnected from evidence, can create narratives that go far beyond what observations actually support, can attribute to conspiracy or deception what might just be normal scientific caution about making claims before data is sufficient to support them, can misinterpret complexity and uncertainty as evasion when researchers are genuinely struggling to understand observations that don't fit existing frameworks cleanly. The challenge is distinguishing between legitimate concerns about transparency and unfounded speculation about cover-ups. What we can say definitively is that 3I Atlas is unusual, shows features that distinguish it from typical comets, carries organic chemistry that's relevant to understanding how life might spread through galaxy, displays X-ray emission that exceeds anything we've observed from previous comets by enormous margins, appears to correlate temporally with spacecraft failure and with planetary defense activation in ways that might be coincidental but that create pattern worth investigating, and raises questions about whether our frameworks for understanding interstellar visitors are adequate, or whether we need to expand our thinking to accommodate phenomena that our solar system-centric experience hasn't prepared us for, whether it's natural comet with unusual properties, or whether it's something more exotic, whether supernova fragment or artificial probe or something we haven't conceived of yet, will hopefully become clearer as the comprehensive observation campaign produces results, as the data gets analysed and compared and synthesized into coherent picture, as the scientific community debates interpretations and tests hypotheses and gradually converges toward consensus about what explanations best fit all observations simultaneously. That process takes time. Takes longer than people accustomed to immediate answers appreciate. Science isn't fast. Science is careful. Science is about testing ideas rigorously rather than accepting first explanation that seems plausible. Science is about building evidence slowly and revising understanding as new data becomes available, rather than committing prematurely to conclusions that might prove wrong. and that deliberate pace is frustration for those who want answers immediately, but is necessary for ensuring that answers are actually correct rather than just satisfying. The organic chemistry findings will continue to be analysed regardless of what conclusions emerge about 3I Atlas's nature, because the discovery that interstellar objects carry methanol and hydrogen cyanide, the measurement of ratios that differ from solar system comets, the observation of molecules forming in the coma through gas phase reactions, all of that is valuable science independent of whether the object is natural or artificial. All of that teaches us about chemistry in space. All of that informs our understanding of how organic molecules are distributed through galaxy and how they might contribute to life's emergence on suitable planets. The protoplanetary disk connection will drive further observations, will motivate searches for methanol in other forming planetary systems, will test whether the molecules we see in 3I Atlas are common products of star formation, or whether they require special conditions to produce. We'll build statistics about how often organic chemistry is present in environments where planets are forming. We'll establish whether delivery of biologically relevant molecules from space is rare event or common occurrence. We'll ground the panspermia theory in observational evidence rather than leaving it as purely theoretical possibility. The methylotroph research will expand as astrobiologists recognize that organisms can be adapted to utilize methanol directly. We'll explore whether such organisms might emerge on worlds where methanol is abundant. We'll test whether metabolism based on methanol, rather than on more complex organics, might be viable alternative biochemistry. We'll examine whether life is more flexible than our Earth-centric assumptions suggest. We'll broaden the criteria for what environments might be habitable beyond the narrow Earth-like category that's dominated thinking about where to search for life. The hydrogen cyanide pathways will continue to be explored as researchers investigate prebiotic chemistry. We'll examine how HCN contributes to amino acid synthesis. We'll test how nucleotide bases form from cyanide precursors. We'll build understanding of chemical networks that bridge from simple molecules to complex biochemistry. We'll establish whether the molecules we observe in space are sufficient to trigger life's emergence, or whether additional steps requiring specific conditions are necessary. All of this represents progress regardless of what the final verdict on 3I Atlas turns out to be, because the object has forced us to confront questions we might not have asked otherwise, has driven observations that are revealing details about interstellar chemistry that we wouldn't have measured if we'd just assumed all comets are similar, has created opportunity to test theories about life's distribution that might have remained purely speculative if we hadn't detected object that fits the profile of panspermia vehicle so well, has advanced multiple fields simultaneously through single observation target that's unusual enough to warrant extraordinary attention. The coordination between space agencies, the activation of planetary defense systems, the intensive observation campaigns, all of this demonstrates that 3I Atlas is being taken seriously at highest levels, that the scientific and security communities recognize that this object matters. That understanding what it is and whether it represents new category of phenomenon or just extreme example of known category has implications for how we prepare for future encounters. That learning from this passage will make us better equipped to respond when the next interstellar visitor arrives, and there will be next visitor, and the one after that, and the one after that. As survey capabilities improve, as we build telescopes specifically designed to detect objects early, rather than discovering them when they are already passing through inner solar system, we'll find more. We'll build statistical sample, we'll characterize population, we'll determine how common 3I Atlas-like objects are versus how common Oumuamua-like or 2I Borisov-like objects are. We'll establish whether interstellar visitors are mostly typical comets that just happen to have originated elsewhere, or whether substantial fractions show unusual properties that challenge our understanding. That's the future of interstellar object research, building from the handful of examples we've studied to comprehensive statistical understanding of population, testing whether anomalies we observe in individual objects are rare outliers or common features, determining what fraction might be artificial versus what fraction is definitely natural, establishing observation protocols and analysis methods that efficiently characterize each new detection, creating framework for rapid response to particularly interesting visitors that maximizes scientific return during brief periods when they're accessible. 3I Atlas will be remembered as pivotal object in that development, as the visitor that forced us to take interstellar objects seriously, that demonstrated they can carry surprises, That showed we need comprehensive observation strategies rather than assuming they're just like solar system comets. That taught us, perhaps painfully through MAVEN's loss, that they can affect spacecraft and systems in ways we need to understand. That revealed organic chemistry that's directly relevant to astrobiology, rather than being abstract astrophysical curiosity. The green glow will fade as the object recedes. The methanol emissions will weaken as solar heating decreases. The X-ray halo will diminish as the coma thins. The anti-tail will become harder to detect as distance increases and as telescopes struggle to capture enough light to reveal faint extended structures. Eventually 3I Atlas will fade below detection limits, will rejoin the darkness of interstellar space, will continue its journey toward whatever destination its trajectory is carrying it toward, will become memory, will become dataset to be analysed, will become reference example for comparison when future visitors arrive, but the questions it raised will persist, the mysteries it created will continue to be debated, the implications of its chemistry and its anomalies and its timing will continue to be explored, because we don't have final answers yet, don't have complete understanding of what we observed, don't have consensus about whether natural explanations are adequate or whether we need to seriously consider alternatives, have only the observations themselves and the multiple competing interpretations and the recognition that this object has challenged us in ways that advance science, regardless of which interpretation ultimately proves correct. The seeds of life that 3I Atlas carries will continue their journey, will remain frozen in whatever ice remains on the nucleus, will survive the passage through our solar system and will persist through millions of years of further travel until perhaps the object encounters another stellar system, another planetary system where those molecules might be delivered, another world where methanol and hydrogen, cyanide and whatever other organic compounds are present might contribute to chemistry that leads eventually to life, or perhaps not. Perhaps the molecules will remain frozen indefinitely, will never find suitable destination, will travel through the galaxy eternally carrying their potential, but never realizing it. That's the nature of panspermia if it operates through natural processes. Most delivery attempts fail. Most molecules never reach suitable planets. Most potential is wasted because the galaxy is mostly empty space, and because the fraction of volume that contains habitable worlds is infinitesimally small. But over billions of years and across billions of stellar systems and with countless objects carrying organic chemistry, even small probability of successful delivery becomes significant, becomes process that might account for how life spreads through galaxy more effectively than independent origin on each suitable world. And we've witnessed one potential delivery vehicle, have studied it as carefully as we could during its brief passage through our solar system, have documented its chemistry and its anomalies and its effects, have raised questions that will drive research for years, have advanced understanding of how universe works and what possibilities exist, have been reminded that the cosmos continues to surprise us and that our frameworks are provisional rather than final, have been humbled by encountering an object that doesn't fit comfortably into our categories and that challenges us to expand our thinking. 3I Atlas came carrying seeds of life and seeds of questions. Both are valuable, both contribute to growth of understanding, both will continue influencing how we think about our place in the universe, and about whether we're alone and about how life emerges and spreads. The object will fade, but its impact will persist. Will ripple through astrobiology and planetary science and SETI and planetary defense and all the fields that its passage touched. Will be referenced in papers and in debates and in future observations of similar objects. Will remain part of the story of how humanity learned to recognize and study interstellar visitors. And perhaps someday we'll know definitively what 3I Atlas was: natural comet with unusual composition, supernova fragment carrying exotic chemistry. Artificial probe seeding galaxy with biological precursors, something else entirely that we haven't conceived of yet. Perhaps observations that we haven't completed yet will provide the evidence that resolves ambiguity. Perhaps future visitors will show patterns that illuminate what we observed in 3I Atlas retrospectively. Perhaps technological development will eventually give us capabilities to answer questions that remain unanswered now. Or perhaps the mystery will persist. Perhaps we'll never know with certainty. Perhaps 3I Atlas will remain example of object that was unusual enough to notice, but not anomalous enough to prove. Will remain case study in how science handles observations that don't fit existing frameworks cleanly, but that aren't sufficiently clear to force paradigm shift. will remain reminded that the universe contains phenomena we don't fully understand, and that some questions might not have answers we can access with current capabilities or within current lifetimes. But uncertainty is part of science, is what drives investigation, is what motivates continued observation and analysis and refinement of understanding. If everything were already known, if all questions were already answered, there would be no science to do. The mysteries are what make it interesting. The anomalies are what make it worthwhile. The objects like 3I Atlas that challenge our assumptions are exactly what we need to continue growing and learning and expanding the boundaries of what we understand about cosmos we inhabit. So we observe, we measure, we analyze, we debate, we test hypotheses, we build models. We compare predictions to observations, we revise when evidence demands it, we acknowledge uncertainty when answers aren't clear. We continue investigating because that's what scientists do. That's what humans do when confronted with mysteries. We try to understand. We refuse to accept ignorance as final state. We keep pushing toward better explanations and more complete frameworks and deeper insights. 3I Atlas has given us opportunity to do exactly that, has provided object worthy of our attention and our capabilities, has created moment where multiple disciplines converge on single target and where comprehensive study reveals complexities that casual observation would miss, has demonstrated that interstellar visitors are worth the effort required to characterize them properly, has shown that they carry information and chemistry, and perhaps implications that justify the resources allocated to studying them. And now we wait for the data to be analysed, for the papers to be published, for the debates to unfold, for consensus to emerge or for competing interpretations to persist, for the next visitor to be detected and characterised and compared, for the slow accumulation of understanding that builds from individual observations into general principles, for science to do what science does, convert mysteries into knowledge through patient systematic investigation that refuses to accept easy answers when evidence suggests reality is more complex. The seeds of life continue their journey, the seeds of questions continue growing, and we continue watching the sky wondering what else is out there waiting to be discovered.